So you should be seeing my screen of RapidMiner Studio, which is our client application to work with all kinds of data sets. So it's in itself an engine to process data on your single machine, but it also has extensions and ways to work with Hadoop clusters, work with different data sources, work with different databases. So the part that I will focus on today is really the Hadoop integration, as that's the main topic of this webinar. So I will show you a couple of ways how you can implement the sampling approach and the other two approaches in the product. So the view that we are seeing is kind of a data exploration view that we specifically created to allow this early exploration phase. So I will just open up one of my Hadoop connections, and it shows me all the tables that I have on my Hadoop cluster. So in this case, for the more technical audience, we are connecting to the Hive server on the Hadoop cluster and fetching the tables from there. Whatever you have access to will show up here. And you can also investigate all the different types of attributes that those tables have, which should already give you a good idea what this is. But the nice part is when you just double click, you can get a small sample of that data. So in this case, we are just pulling 1,000 records. You can change that whenever you wish. But then you can already drill into the data. You can get a tabular view where you see the different values in your data set. In this case, I'm using a flight data set, which became quite popular for demonstrating big data tools. So this includes, each record is a flight in the United States. So in this case, you can see the months, day of the months, departure time, arrival time, what was scheduled and what was the actual, the flight details, the carrier, how much time it spent taxiing in and taxiing out, if it was canceled or delayed for various reasons. So all kinds of interesting details about each flight. And you can go to this statistics view where you can investigate some of these details. So for example, all of my data is from a single year, so it's 2008 in this case, so the sample I pulled only includes that. But I can see, for example, differences in the scheduled departure time. So I can open up a chart where I can see a distribution. There are some more flights in the morning, but otherwise it flattens out and more or less evenly distributed throughout the day. This is really just my sample, so I can already get some understanding how the data looks like. I shouldn't have some huge conclusions based on this because it's really just 1,000 records. I can pull somewhat more if I want to, but this is really just to explore and have some initial idea what the data includes. So this area helps you to explore the data a bit. But if you want to do some more extensive processing, you would almost always switch to something we call the design view. So I just right-clicked on the table and said that I want to create a process out of it. So this is the process concept, kind of a workflow approach that we have here. So how we differentiate between processing on your laptop versus processing on a Hadoop cluster, because it's important to know where the processing happens. Even for an analyst, if you just want to do a simple operation, you want to know if it's running on your full set or if it's running on a sample. So we have this encapsulation called the Hadoop nest. So if you double click and go inside, whatever you do in here will happen on your Hadoop cluster. If you come out, whatever you do outside will happen on your local machine. So you always know when you are organizing these workflows, then that particular computation will happen. So if you want to go for the sampling approach, you build your process outside here. If you want to have a grid computing or a full native distributed approach, you build your process in here. Depending on where you build your process, you have different operators available that you can pull in and that you can add to your workflow to achieve different things. So let me pull up an example workflow that I have created. So in this case, what we are doing is we are doing most of the processing on Hadoop. The only thing that comes out, you will see when I show the inside of it, is a machine learning model. You bring it back into our local machine and store it so we can later reuse it. So that's all that happens locally. All the rest is happening in a distributed way on Hadoop. So let's investigate what's in here. So as I double-clicked here, everything that I am showing here is running in a distributed way, either in a grid computing approach or a native distributed approach. The bottom line here is that you do not necessarily need to know which one you are using. So as an analyst, if I just want to convert my data or prep my data, I'm not even sure if that would require all those machines to be communicating with each other, or that just require the grid approach where I can just filter some records in a distributed way. So basically, typically data preparation, if it does not include joins and big aggregations, then that can be solved with the grid approach, while modeling typically needs the native distributed approach. So let me just start this process while I'll explain what happens here in the background. So as you put together such a process, you typically have these phases as an analyst to go through. So you have some data understanding, data exploration that we have just seen on the other perspective. And then you need to prepare your data for modeling. To get it in a good shape, maybe generate some new features. So this generate attributes panel is exactly doing that. So I have some data on the departure time. So in this case, I'm generating a new attribute that tells me, is it a morning flight or an afternoon or evening flight? I can also generate new attributes that tells me, is it winter? So if it's December, January, or February, I want a binary attribute that describes that, because some models may or may not be able to learn that the months needs to be 12 or 1 or 2, that is winter. So I may be helping some of the algorithms to figure that out. Also, something that the algorithm definitely cannot figure out, which are the top airports. So I need to either manually assign them and say that if any of these airport abbreviations are included, then that is a top 10 airport, or I can build a kind of a sub-process here that calculates the top airports and make sure that those are handled in a different way, so that we just give a flag for those flights that, hey, this is a top airport, those airports might be busy, so keep an eye on those. And then we are just doing some conversions, selecting the interesting attributes that might be good for modeling, and in this case, we are running a Spark decision tree model. So we already have the model built, so it is running on millions of records, so it took some time for the Hadoop cluster to process it. But basically, we have a decision tree where we can see the rules that this decision tree has identified on this data set. So what we are trying to predict here if the flight will be late or on time. And as you see here, if the departure time, the scheduled departure time, is after 11:15 and it's winter, then it's very likely to be late. So the blue one is late and the red is on time. So there is proportionately many flights which are late under these circumstances. On the other hand, here are the ones which are mostly on time. So if you follow these decision lines, if it's before 11:15, it's not winter, or sorry, this one is the most red one, and it's even before 8:22, so probably that is the first flight for that airplane, so there cannot be some earlier delays for other flights that would postpone the departure of this flight. So if it's a very early morning flight and it's not winter, then we are very likely to be on time. So as you can see, very quickly we could combine different approaches. So we could combine more of a grid approach, data pre-processing, with pulling in a couple of these boxes and connecting them. And we could also combine it with real distributed decision tree algorithm that has been designed to be to scale out to multiple machines. And for example, if we wanted to, we could out here pull the result back into memory, in this case just the model, and do some post-processing of it, or pull some sample data and also do some more data exploration on it. So there are really all these options you have at your fingertips to use sampling or use grid approach or native distributed approach for all your predictive analytics and data preparation needs.